All right, everybody, let's talk about what we learned today in 616, Area of Parallelograms. So from some of the questions that we asked, we should now be able to kind of locate where we believe the base and the height of the following parallelograms on this grid's going to be. Now, on this one's nice and straight. It's sitting on a grid line. I'm going to pick that one as my base. Now, in truth, I could pick any of the ones that I want, but it's kind of laying horizontal like this. I feel like this makes it a little bit simpler for me. Then I need to pick a height that's going to be perpendicular. So this is my height. Now this one's vertical. Can you see how the diagonals are the ones that are kind of on the bottom and the top? For those, it kind of gets a little bit harder to figure out where exactly that 90 degrees is going to be, so I like to pick my base to be on one of these sides, the left or right sides. Something that's straight up and down with those grid lines because it helps me find it 90 degree really easy, and then I could use this dotted line as my height. So one of those strategies we talked about is, can you pick any side to be a base? Absolutely. But sometimes, especially when it's on the grid, it's easier to pick one of the sides that's exactly on one of those lines because it makes it really easy to find that 90 degree angle then. So if we look at this, locate the base and the height on the following parallelogram. Well, I have some sides here, some sides here, and some sides here. This 90 degrees is the thing that I'm really interested in though. So for my base, I can see that here's one of my sides and it's with a 90, so that's going to kind of help me. So I'm going to call this guy my base. I'm going to label him base. Now, because I used that 90 to help me decide which side I wanted to use as a base, we also can see that we have this dashed line coming down that is 90 degrees because of this little guy. So I'm going to call him my height. I did not use my 10 at all because although it was one of the sides, there was nothing drawn down to it that was a 90 degree. So because of that, there was no perpendicular, therefore I didn't want to use it. Now another conclusion we can make is that parallelograms that have the same base and the same height have the same area. We pulled that from some of our activities today. So let's take a minute to prove it. We have 1, 2, 3, 4 different parallelograms, all of which use bases of 3 and heights of 4, but they look very different. So we can say area equals base times height. My base is 3. My height is the perpendicular, which is 4. So my area is 12 square units. For this one, area equals base times height. Area equals, here's my base, which is 3. I need to find a perpendicular height, looking for that 90 degrees, so that's a 4. Area is 12 square units. On this one, area equals base times height. My base is a 3. Here's my perpendicular, so my height is a 4. Area is 12 square units. And for this one, I'm going to pick this side as my base. So area equals base times height. Area is 3 times my perpendicular height, which is 4. Area is 12 square units. So what I can see is that although these are all very different looking, if they have the same base and the same height, they will have the same area. Okay, find the missing length of the following parallelograms if the area is 35 square centimeters. All right, so this is 7, and this is something that we don't know. So I know from all my different activities is that area is base times height. Now they tell me that my area is 35. I can see that my base looks like it's 7. My height is the part that I don't know, so I'm just going to leave it as an H. I need to think, what number times 7 will give me 35? And I just try stuff. Does 2 times 7 equal 35? No, that's 14. That's too small. Does 3 times 7 equal 35? No, that's 21. Too small. 4 times 7 would be 28. That's too small. 5 times 7 is 5, 10, 15, 20, 25, 30, 35, exactly what we're looking for. So the height equals 5 centimeters. Remember, this is just centimeters. This is not square centimeters because I'm not talking about area. I'm just talking about one side, which is just centimeters. Okay, if the area is 24 square inches, this is my missing side. Okay, so area equals base times height. My area is 24. I don't know my base, but uh-oh. Which one of these is going to be my height? Now notice this isn't labeled, so take an index card or take a piece of paper or do something and lay it on top to determine that that's going to be a 90 degree. Okay, so I just took my paper and I can see that it's 90, so I'm going to draw that in that this is a 90 degree angle. So I decide, do I need the 4 or the 2? Well, the 4 is the one sitting on that perpendicular, so my height is a 4. I don't need to think what number times 4 gives me 24. And I can find that my base then will be 8 inches. Again, this is not area. This is finding a length, therefore it's inches. This is not square inches. All right, coming down here, select all the segments that could represent a corresponding height if the side E is the base. So we're going to take a look at E down here. We're going to assume that this is my base. If this is my base, I need to find all the sides that make 90 degree angles with it. So it looks like A makes a 90 degree, F makes a 90 degree, M makes a 90 degree, and S makes a 90 degree. So my answer is A, F, M, and S. All of these form 90 degrees, and my thing is writing kind of crazy. Sorry about that. All right, ladies and gentlemen, that's all for today. See you tomorrow.